Hi guys, this is the second part of our homework for 322. We already did the first part, okay? So we're going to start with problem 87 because that's where I left off. And we have to simplify by solving for the variable. So we're going to combine our like terms. So I have a negative 2m and a positive m, which means that I have negative 1m or negative m left. And then an 8 and a 1, they're both positive, so that would be 9 equals 0. Then because there is a negative variable, I'm going to flip it over onto the other side to make it positive because we always need to have that variable being positive. So I'm going to add m on both sides, which means that I have 9 left on the left and m on the right. So that is done. You could have subtracted 9, but then you also would have had to make the opposite, do the opposite of m. So you could have done it that way, but it adds more steps. So that's why I do it that way. All right, then here, again, there's my equals sign. So I have 2 equals, how many x's? I have an x and a negative 2x, so that would be negative x plus 6. I'm going to move my x over onto the other side so that it's positive, so plus x on both sides. So I have x plus 2 equals 6. And I need to subtract this 2 to get the x alone. 2 minus 6 is 4. So x equals 4. Okay, so there are those two. Now, Mr. Wallace has added it again, and we have to fill in his missing table. So the first thing that I like to do is write my table out in order. Now, I saw that I was given the 2 and the 10. Those two were given to me, so I put those in. And then I counted and I said, okay, how many jumps does it take me to get from 2 to 10? That's a jump of 8. And then I plugged in the y values that I knew, right, that I was given. And I said, okay, what's the difference between 10 and 50? And I know that that's 40, right? So then I can divide. So I can say, how many times does 8 go into 40? 5, right? So that tells me that every one of these jumps, we're adding 5. So plus 5, right, all the way down. So let's fill in our table. So we have 10 plus 5 would be 15, plus 5 would be 20, plus 5 would be 25, and then 30, then 35, 40, and then 45, and that makes 50. So that means that we did it correct, right? To work backwards, again, we can do that. We just have to subtract 5 instead of add 5. So 10 minus 5 is 5. 5 minus, sorry guys, 5 minus 5 is 0. Oh, if this was 0, sorry. This is not 0, this is 1/5. If 0 was up here, then that would be 5. 1/5 is going to be somewhere in the middle, right? It's going to be a fraction. Somewhere in between here. Wait a second, what did I do wrong? Okay. Oh, this is 0. Oh my goodness, I'm going to lose it, you guys. This is 0. Because when I subtract 5 from 5, I get 0. Okay. Then, if I wanted to divide this up even more, right, I could tell that 1/5 would just be like, I would have 1/5, 2/5, 3/5, 4/5, and then 5/5. So I can tell that this would actually just be 1 if I'm going up by fifths. Okay, so we have that. Let's see what we can fill in over here. I don't see 60 yet. That's going to be somewhere down here, but I can extrapolate this, right? If I was going to get to 60, I'd have to go 55 and then 60. So that would be 2 jumps away from 10, which would mean that that would be 12. So 12 would match up with 60. And then, okay, 3, I already have that. That's 15. 1, I have that. That's 5. See how we can kind of just add in these things? 1/5, we already figured out was 1. I could, right, work all the way down to see what that would be. Or I can write myself a rule. If we write a rule, y equals, remember, what is my growth? How much am I adding every time? 5, x, and then my 0 number here is 0, so just 0. Then I can plug in this 365 in for y. So 365 equals 5x. We have to divide by 5, right, to get the x by itself. And then when we plug this in on our calculator, how many times does that go in? It goes in 73 times. So that tells me that when y is 365, x is 73. Okay, just like that. Alrighty, for the next one, again, I wrote it out in order here, right? Because it's so much easier to see when we have our x values in order. Then I could see that from 5 to 10 is a jump of 1, 2, 3, 4, 5. And I know that my jump here, right, from 12.5 to 25 is 12.5. That's like half. That's halfway. So then when I go ahead and divide this, right, by 5, I get 2.5. So that tells me I'm going up every time plus 2.5 every time. So if I was going to fill in this graph, right, if I add 2.5, that would be 15. And then 17.5. Helps if I do my math right. 20. And then 22.5. And then 25. Perfect. I can also, right, work backwards. I can take 2.5 off, so that would give me 10. And then that would give me 7.5. And then 5. And then 3.5. I have to think about that in my head as I'm going. Right, but we could work backwards. Okay, so when my x value is 1, I can see that I'm at 2.5 up here. Oh, this should be 2.5. Helps, man. All right, 2.5. If I'm at 20, I can essentially, I can double, right, my 10. I could think of it like that. Well, I know 10 is double 20, so I can double 25 to give me 50. And then I can continue working that way, or I can write myself a rule. So if I write a rule, y equals, what am I going up by each time? 2.5 x. And then if I were to take this down to 0, right, that would mean that I would have 0 left because I take 2.5 away. I can plug these numbers in then. So these are my x's. So I could say y equals 2.5 times 30. All right, I could punch that in on my calculator and I would get 75. I could also plug in y values. So for this one, I could use my rule. This is my rule right here. I could say y equals, 0, this is my y, equals 2.5x. And I could solve for y by dividing by 2.5 or 2.5. Right. And then I would have x equals 0, because that's nothing. Right? And then for 35, I could plug that in. And if we do that, then we have 14. All right, guys, I hope that helps. Thanks for watching. That was 322. Bye.